Hello students, welcome to Educare. This is Bihani and we are going to see an important concept in chemistry, that is about the formation of covalent bond by valence bond theory. This video is as per a demand of our one of the subscriber, and we are continuing for that purpose to know you details about the valence bond theory. Well, you might have known a covalent bond, how it is formed. It is formed by the mutual sharing of a pair of electrons such that both atoms which form covalent bond give one electron each in the bond formation. But this is not enough or not sufficient to explain the complete process of the formation of covalent bond. That's why the required theory for that purpose, in old days the scientists were trying actually how covalent bond is formed, and two scientists, Hitler and Lander, they have given this valence bond theory, which was further extended by Pauling and Slater, and then this theory come into existence. Okay then, we discuss one by one point what that valence bond theory deals with. We already know there are orbitals in an atom which contain electrons. For example, s orbital, p orbital, d orbital, f orbital, and they contain electrons in them. Now, when a covalent bond is formed, as per we know definition of covalent bond, a pair of electrons shared between two atoms, but actually electrons are present in the orbital, and then according to this valence bond theory that called as VB theory in short, there are orbitals overlap. So according to VB theory, overlapping of atomic orbitals gives rise to covalent bond. There are few conditions when that overlapping takes place, how that overlapping takes place. The first condition is that overlapping orbitals should be of the nearby same energy, first thing. Second thing, the orbitals overlapping should have one unpaired electron each, means they should be half filled. Now what is this half filled? For example, every orbital S, P, D and F, individual orbital capacity is 2. Now even if p orbital has capacity 6, but there are 3 p orbitals, therefore the total is 6 electrons. So we come to know now that every orbital has capacity 2 electrons, and half filled means that contain only one unpaired electron. Generally it is shown in block diagram something like this. It is shown in the block, it is presence of 1 electron. If there are 2 electrons, they are shown like this with opposite spin. Spin, that is electrons when they revolve, actually they revolve around the nucleus as well as revolve around themselves. According to that, two kinds of revolution there, clockwise and anti-clockwise. Depending on that, this upward arrow and downward arrow is shown. When it is single electron, it is shown with upward arrow, that means clockwise spin. Now, two orbitals containing unpaired electron with opposite spin means something like this situation. Now, according to VB theory, a covalent bond is formed when two half-filled orbitals overlap with one unpaired electron each containing opposite spin. What happens? For example, two hydrogen atoms, when they come closer, we know hydrogen has only one s orbital, and then they should have such situation, their electron shown with opposite spin like that you observe here. This is the s orbital called 1s orbital of two hydrogen atoms, and when they approach each other, the overlapping occurs in this manner. This is how H2 molecule is, and that overlap region is shown by shaded part. So it is here 2 electrons now in the overlap region. What happens? The number of covalent bond formed according to valence bond theory is equal to number of unpaired electrons present in the orbital of that atom. For example, hydrogen has one unpaired electron, therefore it can form one covalent bond. However, this concept of presence of number of unpaired electron is equal to number of bond, which is ultimately valency, is not complete true due to that some exception there that we'll discuss afterwards in the second session. Here it is sufficient to know such kind of overlapping occur. For example, this H2 molecule. Take another example. Suppose formation of HF molecule you want. Hydrogen's 1s orbital and fluorine's 2pz orbital that overlap. That overlapping can shown something like this. This is hydrogen spherical orbital and that contain unpaired electron. This is a pz orbital of the fluorine is containing unpaired electron, something like this. and that's shown with such opposite spin. Now it is shown this opposite spin, and they are getting now neutralized spin, and after overlapping it is this situation. Overlap region is shown here, that reduced slope. We have that px, py and pz. Out of that, pz is taken, this is the overlap region. This is how HF molecule is formed there. Now this means it is a kind of example of sp orbital overlap. During overlapping, after formation of covalent bond, the neutralization of spin takes place. Neutralization of spin means the two electrons now get adjusted in the overlap region, and the strength of covalent bond according to VB theory depends on the extent of overlapping. Extent, that is how much overlapping occur. The stronger bond is formed by greater overlapping, that is greater extent of overlapping. Then about the another example, if you consider, suppose how halogen molecule is formed. For example, if you want to know how chlorine, that is Cl2 molecule is formed. Chlorine, we know its atomic number 17, its configuration shell wise 287, and when you write detailed configuration like 1s2, 2s2, 2p6, 3s2, then 3p5, and further this 3p5 is 3px2, 3py2 and 3pz1. Can you observe 3px2, 3py2, but 3pz is 1? Means there is only one unpaired electron in case of chlorine, and that is in 3pz orbital. Therefore, two chlorine atoms, when they combine by overlap called pz overlap, actually 3pz overlap, something such molecule that we get. It is the diagram of that how that chlorine Cl2 molecule form. This is the overlap region. This is its 3pz. These are respectively 3px and 3py, like here of another fluorine 3px and 3py. So that is the example of pp orbital overlap. There are three types of overlap when we concern sp orbitals. First is ss orbital overlap, then it is pp orbital overlap, and then it is sp orbital overlap. So this is the basic concept about VB theory, presence of unpaired electron, number of unpaired electron gives valency. About that second part we will take in the second session, and that will conclude in the next session. As we have come to an end, like this video, comment which concept you want to see next, share this video with your friends, subscribe to our channel, and don't forget to click on that notification bell icon.